Hello, welcome to our digital driving transformation for state and local government session. This is part of our overall set of sessions for that subject. This specific session is for data analytics to improve forecasting for civic infrastructure, with emphasis on civic infrastructure. My name is Ed Blake. I'll be facilitating, I think, every session that we have. So we're lucky enough to have a great set of attendees today to talk through this very interesting topic. And I think we're going to start with sort of framing up the challenges and what we need to know. So I'm going to actually jump in and give everybody a chance to introduce themselves. Again, we have a really great panel of experts today. If you guys could introduce yourself, and then we'll jump in.
Sure. I'm Eric Jacobson. I'm a managing consultant at Catapult. I work primarily as a project and product success manager with teams solving data and AI problems.
My name is Andrew Kramer. I'm a senior data scientist with Catapult. I specialize in building custom machine learning solutions and putting them into production.
My name is Samir Patel. I'm also a senior data scientist at Catapult, and I specialize in building custom machine learning solutions for our clients.
Thanks very much, guys. Again, my name is Edwin Blake. I'm facilitating the sessions as part of our summit. Going to quickly show our agenda before we jump in. Eric's going to start us with sort of framing up what's needed by a city planner to be successful in the arena of civic infrastructure, which is going to be a great start. We have four other topics to jump through, open discussion with our experts here. So let's just jump in. Eric, can you kick us off with what the city planner needs to be successful? Thank you.
Sure. So, short of training as a city planner, I think a common challenge, a big challenge that a lot of planners of physical civic infrastructure face is that the processes that are required to plan, get community input on plans, arrange financing, build and staff new facilities that are sized and located based on demand. Think about, schools, fire stations, things of that sort. Those processes can take many years to come to completion. So it's not enough to know kind of where you need more school capacity right now, or where you could use some additional firefighters right now to respond to calls that they get. You really want to know where that demand is going to be and how much of it there will be, to the extent possible, when these things get built. And of course, they have access to data from a variety of sources that can help forecast the amount of demand and where it'll be needed, but it's imperfect. It's generally very difficult for people to just look at it and forecast how the confluence of all the trends that data represents will shape demand in 5, 10, even out to 30 or more years into the future. And these are expensive facilities that have useful lives that can span those kinds of durations. So what they're always looking for are better ways to forecast and feel confident that these investments are sized and located as optimally as possible. And of course, data scientists like some of my colleagues here have some tools that can help with that.
Absolutely. And I would just add on to that real quick, is that a lot of the time the planners have a lot of different information coming from a lot of different data sources, but I think that it's also incredibly important to realize the kind of the tribal knowledge, the working in the weeds of the conversations that school planners have with principals and other planners that get a pulse that is not captured with data. Because when we're looking to make a city planner successful, we need to give them all of the tools that we can possibly provide them and the acumen that they have outside of things that are captured in data. So Samir and I have previously made a couple of these forecasting models in terms of trying to identify where people are going to be in the future. So Samir, what are some of the data requirements? What are some of the key features in your experience that you found really drive a successful way of trying to figure out where people are going to be?
Well, data requirements for a machine learning model are obviously a large enough data set that we can actually train a model on. Organizations spend all of this money on collecting data, and it's important to find a way to actually utilize it. So, uh, really, the answer to that question depends on what the organization is trying to extract from their data. What problem are they trying to solve? If it's a population growth issue, things like the number of bedrooms in a parcel or the population at a certain granularity along the region that they're trying to solve for would be a good thing to include in the data set.
I think Yeah, I completely agree with that. And I think that a lot, as the way that I like to think about it is if you're trying to predict people, try to get as much information about people. And if you're trying to think in terms of time, you need a history as well. I think that this is where a lot of people get caught up in different machine learning projects like this. A lot of the time, people only have the current information and then they dispose of the history because maybe they're active systems don't use it, but it's extremely important, especially if you want to do forecasting. You can't forecast 5 years on 1 year of data. Really, ideally, you have at least 15 years of data before you try looking forward.
Mhm. Exactly.
Thank you.
So, and then I guess we can move to our next question, which is why is machine learning especially well equipped for a problem like this and trying to figure out where people are going to be, even if we're relying on real estate data or census data? What positions machine learning well for something like this?
Well, machine learning is important because it has the capacity to digest a huge data set, or depending on how huge you want it to be, and it really establishes trends in the data a lot better than traditional mathematics and statistics could do. Um, there are multiple different types of machine learning, so again, it boils down to what problem the organization is trying to solve. For forecasting, there's supervised learning, which data scientists supply algorithms with labeled training data. And there's also unsupervised learning. So we can establish trends regionally based on like clustering the data or um, something like that.
Yeah. And in some of our exercises, we've used both of those different types of machine learning. You know, in using the real estate data, we know where everybody is at what point in time. Not everybody, but we know where the homes are. But you can't make a prediction just on an individual home. So figuring out what is a similar group, how do you define a neighborhood? Well, a lot of times the neighborhoods aren't labeled, or if they are labeled, it might not really capture the essence of the neighborhood. So you can create these custom groupings, unsupervised, and then from there try to forecast what the future growth for these custom created geographies will be. And the reason, and then you can do the forecasting, which is the supervised method that you did. Another reason that I think that machine learning is great, rather than a, you know, what was last year and the year before that, let's average that amount and then that, that change and then look forward. What that doesn't capture is all the idiosyncrasies of the data, or a more simple like linear regression, because what a machine learning model is really good at is finding relationships between different pieces of information. When we feed a machine learning model data, 1 plus 1 doesn't necessarily going to equal 2. Maybe we see that the first one represents something more powerful in one case, and then maybe in a different case, 2 is going to be something else. So machine learning makes our lives a lot easier because it's able to find those patterns that we as humans struggle with a whole bunch more. So in building either a machine learning model or a statistical model, I think that there's a lot of worry, I feel, or a little bit of black magic. Like how do we know what it's doing? Is it going to take over, et cetera, et cetera? How can we trust something like this? How do we know if a machine learning model is going to be successful?
Well, the baseline measure for testing whether a model is successful tends to be accuracy when discussing machine learning, or some F1 score precision or something along those lines that's quantifiable, a percentage of, how much did the machine get right compared to what was actually right. So the way to do that would be using a holdout or validation data set to test the model on after training.
So would this holdout set, would the model see that information while it's being trained, or what does that holdout set mean?
No, it is not seen by the model during training. It's, say you have 15 years of data and you want to create a model to predict 5 years into the future. You would use the first 10 years of that model to train, or the first 10 years of the data to train the model, hold out the 5 years to test, or hold out just one of those years really to test whether the machine is, or the model is accurate or not.
Yeah, on things that it hasn't seen. Because if the model only performs on data that it's seen, then how do you actually know it's successful? And this is one of my favorite topics as a data scientist, because it kind of shows where some of the nuance comes from. It's getting easier and easier to use the different data science tools, but when to use what tool and how, I think, kind of goes back to some of your previous points. You'd mentioned, the F1 score or precision or recall, and everything, I think, really depends on what is the problem that you're trying to solve. Does it matter more that you are making you know, identifying rare occurrences and identifying them? Like, how bad is it if you mislabel somebody who has cancer? Like, how bad is it if you accidentally don't flag a spam email? So figuring out how to measure these things, how to define your holdout set without having your model cheat, it's a really important part of this process, and it's definitely applicable in problems like this when we are trying to predict where people are going to be. Because if the model is able to peek ahead, then it's going to be right far more, and then it probably won't generalize to the unseen data.
Very true.
Absolutely. So I think that the next thing that we should probably talk about, and this I think is one of the most important things, and Eric has done this in not just machine learning projects, but also data projects and all sorts of different things. Who needs to be in the room, from either the county, the city, the state, in order for a project for this to be successful?
Yeah, absolutely. I mean, I think those of us who work in the technology space know that a lot of projects succeed or fail based on governance. So what does that really mean? Not to just throw out a buzzword and then walk away from it. It means the people who are going to be responsible for the decisions that you make need to be engaged and understand what's going on so that they have confidence in it. When they have concerns, they can weigh in and you can address them. Obviously, the planners themselves who are gathering some of the data and doing some of this work. The data set owners. So when you start thinking about what are our data sources, where do they come from? You got to think about who owns that data and do we have permission to use it? And if, for example, we have 15 years of construction permit history, but they've changed construction permit enterprise systems twice during that period, and the data is not formatted the same way. You got to think about how is there a way that we can normalize or align this data in such a way that we have a consistent history. So you're going to need some data engineers involved. Never to be forgotten and often overlooked in technology projects of all types are the end users themselves. So if you're building a forecasting model for building where should we build schools, you're going to want to have people from the school district involved and get their input. If it's fire departments, you're going to want to talk to the fire department. Various groups like that, because what are the things you're going to need, right? You're going to need access to data. You're going to need people that can help explain the data or any discrepancies you find in it if you're trying to clean it up and make it usable. You're going to, all of these tend to be, you're talking about spending millions of dollars on something that benefits one community versus another, and how big will it be, and is it as nice as the one in the neighborhood next door? You need to be able, to some extent, to justify the decisions that you're making. And to what Andrew spoke to earlier, that tribal knowledge is important at the outset and throughout the process, because you can kind of anticipate, because these are political processes, a lot of them require community input. What kinds of concerns or questions or assumptions are people going to walk in the door with? And if your model is telling you something that's different than what that tribal knowledge is telling you, it bears a conversation, at least to say, here's why we think our tribal knowledge may be not completely the best predictor of this forecast, so on and so forth.
Yeah, I definitely agree, especially with that last point, because a lot of the time, especially with these business solutions, because there's so much information that is not captured, the model is not going to be perfect. What you're looking for is a model that is better than what you had before. So being able to get these people with this, with this business sense, with this tribal knowledge, whatever you want to call it, and get them to understand generally how the model works and know when to really lean into the insights the model is providing, rather than looking for opportunities to try to prove the model wrong, I think is the synthesis of leveraging the technology and leveraging the things that you already know. So yeah, but it's definitely a really fun problem. We've been able to tackle it a couple of times, and the nuance is always there. But yeah, it's data science on state and local government is never a dull moment.
Well, thanks very much, guys. That was a great session. I really appreciate your input and your expertise. That was really useful, hopefully, for our viewers. It will be. Thank you. Thanks to our anyone who accesses our presentation, our discussion here. I hope it was useful. Certainly, really, again, appreciate our experts attending today and sharing their knowledge. If you feel that you'd like to connect with one of our experts, you'll notice on the screen there's a QR code, both to do that, to connect with our experts if you'd like to and learn more, and also we'd like to know what your feedback is. Short survey, how we did, if we need to change the way our format, or if you have input, if you have comments, we always would really like to hear that. Again, this is your facilitator, Ed Blake, facilitate all of our sessions for this summit. I really appreciate your time. Thanks very much. And please feel free to contact us if you need more information. Thanks again. Bye-bye.